Okay, so we've learned transformations, and this is not new to you guys at all. We have already learned transformations. Now, what I want to kind of show you on this is the part that I'm highlighting right there. That's really the exponential. That's the elementary function. The elementary function is just something like y equals 2 to the x, y equals 5 to the x, that kind of thing. That's what we're looking at. Anything other than that is changing this around a little bit. So one of the things that we learned before was if the things are outside the function. So if you're outside of the exponent, that's either going to be up, down, or it's going to be stretch, shrink vertically. That's what it does, okay? So it's the same as it is for any problem you've learned before. So this minus 1, what do you think it does? Down 1, good. Okay, so that's down 1, okay. All right. Now that 3, you're multiplying something by 3. So if you multiply y by 3, y gets bigger, right? Okay, so does that stretch or shrink? It's bigger, stretch. So we would say a vertical stretch, okay, by 3. And then the other thing is a negative. What did a negative typically do? Like go back to a parabola, x squared. You know that a parabola is the U shape. What if you put a minus in front of the x squared? What does it do? Reflects it over the x-axis. Good. Okay, so we would say that reflects over the x-axis. Okay, so that's how you know those things. All right. So there's a lot of similarity to what I'm doing on all these problems here. Okay. All right. And let's look at this next one. All right. Let me just ask you, what do you think the plus 10 does? Up 10, exactly. Okay, what that's doing is making y bigger by 10, so it's up 10. Okay, how about the 3? It's not much different than the last problem. Stretch, that's a vertical, and you want to make sure that you put vertical stretch, okay, by 3. Okay, now here's one that's a little different. That negative x, now think about what that's doing. It's making x values go to the opposite. So 3 goes to negative 3. 4 goes to negative 4. That's a reflection over the y-axis. The better you understand this, the easier it is to remember all this stuff. I look at that and it's just that if x is opposite, then it's changing over the y-axis. Okay, like that. Okay? All right. And then a lot of similarities. Next problem, what do you think the plus 1 does? Up 1, so that's easy enough. How about the 1/4? What do you think that does? Shrink, vertical shrink, good. Okay, so that's vertical shrink by 1/4, okay? Now let me see what you think about this. Now this is x minus 3. It's inside the exponent, so that's left-right stuff. What do you think, right 3 or left 3? Right, okay, good. Remember how everything was opposite? Okay, so see, it's all the same. So this would be to the right 3. Okay, so that's how that goes. Okay, all right, good. Okay, next one, the 4 is a vertical stretch by 4. Okay, the negative is, now that's making y change, so that's reflecting over x. Okay, now this 3 is weird, okay? See, that's inside the exponent. So remember, anytime you're inside the function, everything's backwards. So actually, you might think that that is a stretch, but it isn't. What it is it's a horizontal shrink by the reciprocal by 1/3. That's the same stuff that we learned with any other function. Anything that's inside of the exponent is going to be backwards to you, okay? Just like x minus 3 is right 3, not left 3, okay? All right, next problem, the 8, that's up 8. How about the 0.2? Now that is outside the function, so it's vertically stretching or shrinking. Which one do you think? shrink, shrink, shrink. Okay, that's not inside the exponent. So that would be a vertical shrink. And that's because y is getting smaller. You multiply a number by 0.2, it gets smaller. So it's a vertical shrink by 0.2. And then that leaves us with this 0.3. That's inside, so it's horizontal stretch or shrink. So this is actually horizontal stretch by the reciprocal. So that would just be by whatever 1 divided by 0.3 is. I don't know what that is off the top of my head. I think it's like 3.3 or something like that, if I'm doing that right in my head. So 1 divided by 0.3 is, yeah, about 3.3. And see, if you take the reciprocal, then it starts making sense to you why it stretches instead of shrinks. Okay, that's kind of weird, but that's the way functions work at their inside. Okay, all right, so you guys are doing good. All right, let's go through at the bottom here and just kind of look at the graph. So there's a web work problem on 6.2 a lot like this. So first of all, you have a bunch of translations on here. The one that is 2 to the x, and I think what I'm going to do is just kind of have you label these like this. The one that you might not be able to see my colors. Can you guys see colors on this at all? Sort of. Okay. All right. Well, that's what 2 to the x is. That's the basic one. Okay. That's an exponential growth function. That's the one everything is going to be changed with. Okay. So if you kind of go through and look at this, one thing that we learned is if this number right here is like bigger than 1, okay, that makes exponential growth. Everything just goes up. But if the number is smaller, then that makes the graphs go like this. That makes exponential decay. So there are 2 decay functions on this problem. There are the 0.25 and then there's the 0.5 like that. Okay. And one way to look at this, you can look at your graphing calculator to kind of look at this. So I'm going to put in the 0.25 to the x. Whoops, not like that. You got to go like 0.25 raised to the x. What am I doing? I keep putting the wrong thing in. So I'll put in 0.25 in parentheses to the x. And then, if you just do zoom 6, a standard window, you can see that that's exponential decay. And if you put the other one in, which is 0.5 is a little bigger, it's just going to affect how it decays. Okay, so if I put that in, okay, that's this one. So I'm going to just have you label this one as B and that one as C. So the 0.25 of x is B and the 0.5 of x is C. Okay, like that. And what happens is it just changes how fast it decays. All right, so what'll happen on this is this one is this one is a little bit faster decay. Okay, it's just steeper. Okay, that's just the way that the numbers work on that then. Okay, the other 2 we want to be able to do without looking at our calculator. So if you go down to this one, what does this 2 do on number 5? That's a vertical stretch, right? Okay, and so is number 4. That's also a vertical stretch. So which one do you think would be steeper if you multiply something by 2 or multiply it by 3? Multiply it by 3, good. Okay, so this one, number 4, that would be the one that's in green from my perspective. I'll call that one D, and then the other one would be E. Okay, so that's just kind of an exercise to show you, how these things change a little bit. What I really want you to know on that is automatically, number 2 and 3 are exponential decay. Does that make sense to both of you? Why that is? Okay, all right. And 2 to the x is growth. Okay, that's the idea. Then 4 and 5, the difference in the growth function because you're stretching more on number 4. That's why it's got to be the steeper graph. So that's the idea. Okay?